Hi, how are you? Enjoying the holidays at home? Come on, let us do something. Uh, we discussed about food toxicology and cosmetic toxicology, and now it is a time to deliberate upon a very good subject that is, we call that as medical toxicology. And when we talk of medical toxicology, we say that this is the real toxicology. Medical toxicology is the real toxicology. Paracelsus was a man of medicine. Claude Bernard, Orfila, Zibin, even the person who has written a very good book on medical toxicology, Wallace Hayes, a very good friend of ours, stays in USA. He has written a very good book on medical toxicology. It is there in our library. You can go and see that. The beginning of the medical toxicology is through, if you go to the history of medical toxicology, you will find it that people started talking of medical toxicology after World War II, especially after World War II, because then the Vietnam War, then the Syria War, then the other wars, they all have experienced at some level or the other the chemical poisoning caused by the war chemicals. And that was the beginning of this particular science of medical toxicology. The medical toxicology, as such, started with the mission, and that mission was to first to know about the war chemicals. Then the second mission was to know the toxicity of those war chemicals. Then the third mission was to prevent the toxicity of those chemicals, and the fourth point was to prevent this toxicity. With this, the people started concentrating on medical toxicology, and the crux of the subject is the health risk assessment. There was a time when I delivered a lecture in International Congress of Toxicogenomics and Proteomics long back, maybe 15 years back, and that was dealing with I deliberated upon the molecular markers of human health risk assessment, and that dealt with the health risk assessment. So the basic point with this is the health risk assessment. How we can perform this health risk assessment, who can perform this health risk assessment, what are the tools of health risk assessment, this is to be talked about. If you just go into the subject, deeper into the subject, whose responsibility is to take care of the human health? WHO. Whose responsibility it is to take care of the environmental health? EPA. Whose responsibility it is to take care of the occupational health? OSHA. Whose responsibility is to form the threshold limits? ACGIH. These are some of the international organizations, including IARC and others. They had been involved in medical toxicology right from beginning. Each one of them has got its own objectives and own mission, and these are some of the agencies. Then where do you stand? Do we have a responsibility towards human health? Yes, we do have. As a student of toxicology, we do have a responsibility to take care of the human health, not to only human health. Recently, these medical toxicologists, they have started an initiative, that is the public health initiative, where we all are working on risk assessment, that is the human health risk assessment. That is the planetary health initiative. Lancet is a journal which is published from England, and that Lancet journal has started this initiative of having the planetary health assessment. That is further goes beyond the concept of health risk assessment. Many countries, they perform health risk assessment in their own ways. They have got their own methods to do that, and they have got their own nomenclature for that. And if we talk of the nomenclature, we come across with many words. which you have already studied. And these words are like, we have studied the toxicity, the intoxication, hazard, poison, the chemical poison. These are all the words which have been used in its vocabulary on its as a nomenclature. So the mass poisonings, they have occurred since beginning. Maybe accidental mass poisoning, maybe deliberate mass poisoning. Deliberate is the when we use it in war against the enemy, and the accidental is that occurred in Bhopal gas tragedy. Accidental is the Semenso Italy episode. Accidental is Love Canal episode. Accidental is the Chernobyl accident. And these come under accidental poisonings, and there are some deliberate poisonings. The deliberate poisonings are performed especially during the war. Accidental poisonings occur in due course of time. So we proceed further with this subject like this, that we have got the medical toxicology has got a mission, then medical toxicology has a vocabulary, then medical toxicology has a, what you call this as detection, how we can detect the presence of a particular chemical. We deal with the acute effects, the sublethal effects, then the chronic effects. You know all that very well. And we go from the simple screening to the sophisticated methods. Uh, we perform the biological monitoring experiments. We go to set the guidelines in the form of biological exposure indices. We go for the concept of threshold limit values. We go for the concept of LOEL or NOEL. This all comes under the aegis, under the umbrella of this very good subject of medical toxicology. Then we think that the medical toxicologist should know about certain things, like he should be well aware with the concept of biological monitoring. We had been practicing biological monitoring, for last 25 years. We have monitored human population against the occupational exposure to lead, benzene, trichloroethylene, arsenic, and many other drugs, or many other xenobiotics. Even alcohol exposure in drivers, the benzene exposure in petrol pump workers, the trichloroethylene exposure in the dry cleaners, the lead exposure in traffic policemen, in the Khurja pottery makers. That comes under human health risk assessment. And the method of assessing the human health risk is just a simple one, that is through the application of the concept of biological monitoring. Biological monitoring has got three more types. Like, one is the environmental monitoring, then is the biological monitoring, then is the biological effect monitoring. When it comes to effect, it becomes the systematic study of the health effects of a particular chemicals that falls under the scope of the human health risk assessment. We have got this concept of biological exposure indices. These very good effort being made by ACGIH. You already know what ACGIH we discussed in regulatory toxicology. ACGIH performs the experiments, takes the advice of the senior scientists or toxicologists around the globe, and then they set these lines. Say, for example, arsenic. In the case of arsenic, earlier we used to allow the 100 micrograms per liter in water. Then we came down to 50 micrograms per liter. Now it is only the 10 micrograms, and people say it should be now 5 micrograms. So they keep on revising the biological exposure indices. This is a ongoing process where they keep on affecting it. What a medical toxicologist should know all these units. He should know about the biological monitoring. He should know about the biological exposure indices. He should know the toxicokinetics and toxicodynamics of a particular chemical, how it is being taken up, how it is being absorbed, how it is being transported, how it is being metabolized, and how it is being excreted. And through, biological monitoring definition says that it is the determination of the chemical or its metabolite in the excreta or secreta. In this way, we perform the subject of take the experiments in biological exposure indices like this. Then there are other, we go, human health risk assessment doesn't stop here. We go a long way. We go to form the you see, we had written 2 3 articles as a new paradigm in the human health risk assessment. That is the application of toxicogenomics, application of proteomics, application of metabolomics. These are the new approaches made for human health risk assessment around the globe. Many laboratories are doing it. We are also doing it. That we identify the effect which may occur at the genetic level. We identify the effect that may occur at the protein level. So these are some of the new concepts. Toxicogenomists say that now the entire world is in our hands. They say that the globe is there and we are keeping this. This is the separate story about the people who are working on toxicogenomics. So right from the responsibilities of the agencies, then the responsibilities of the university professors, the responsibilities of the students of toxicology, that all takes care of this big subject of human health risk assessment, uh, which is the crux of the subject of medical toxicology. So we can proceed further. We can go for how we can analyze the toxins and their metabolites. Then there are certain opinions, the opinions, viewpoints of the biologist and the medical scientist. Then they keep on working on the biologist, they call it as experimental toxicology, and the medical people, they call it as epidemiology. We go to molecular epidemiology, we talk of epidemics. Earlier we used to talk of epidemics, and now we are talking of pandemic. The coronavirus is a pandemic. So that occurs at the global level, at the very large scale. Epidemic is a small scale. So these are the terms which are used by medical toxicologists. Then it includes the chemical evaluation and the statistical application. So these things, they are there. Then what a medical toxicologist is supposed to do, he is supposed to prepare a complete toxicological profile of a particular drug or a chemical. And that profile is, you can go to the website and find out ATSDR. You all know that what ATSDR is, Agency for Toxic Substance and Drug Registry. You put benzene, you put arsenic, and they give you the complete profile, toxicological profile of arsenic. From where it comes, what are the environment, what are the industrial uses, how does it enter into the ecosystem, how it is absorbed, how it is transported, how it is metabolized, how it is excreted, and then what are the effects at the cellular and the molecular level. That makes the toxicological profile. So that profile is being prepared by different agencies, and it is the product profile. And after that, we prepare the toxicology data sheets. This is very similar to the profile, but like OSHA, ICGIH, WHO, they prepare these toxicological databases. Then how to evaluate the human health. We evaluate it through basic application of the basic concepts, like whether it is an hazardous, whether it poses any risk, that risk is really statistically significant. And we perform this risk assessment through the tools of toxicovigilance. I had been talking to you is this toxicovigilance and pharmacovigilance earlier also. So this assessment is done, and what do we get? We get after this assessment some concepts like NOEL, LOEL, you already know it. the concept of LC50, LD50, TLV, these are very old concepts. We go for LOEL, NOEL, and we perform the cellular and toxicological studies using the concept of QSAR, quantitative structure, activity, relationship. So these things keep on going. And then we evaluate a hazard, and to evaluate the hazard, we consider the prognostic criteria, and these prognostic criteria include the epidemiological criteria, the quantitative and qualitative criteria, and then we make the interlaboratory comparisons. What my laboratory has done and what your laboratory has done, that data is to be compared. And then finally we come down to the ecotoxicology, that is the environmental aspects, like the concepts of biomagnification, eco-magnification, or the acid rain, or the climate change, or the effect of the climate change and phase effect of the climate change on the metabolism of a particular chemical. These are very hot subjects of today, and they fall under the scope of the this medical toxicology. Then dose evaluation or dose preparation, that includes the effect of small doses, that is the whether these they may lead to any disease. Medical toxicology is, you see, is a very good subject where we talk of the drugs, the sulfonamide poisoning, the thalidomide poisoning, right? All these things, they are covered in Minamata, they are all covered in medical toxicology. And medical toxicology in a very systematic way keeps on going and working and against each and every chemical. If I say that more than 1 million chemicals have been synthesized in different laboratories throughout the globe, how much we know about their toxicology, how much we know about their toxicity. Do we have data sheet for 1 million chemicals or drugs? No, we do not have. And then there are the concepts of co-exposures, that the exposure doesn't occur to one. There are certain other factors, including the what is the fate of a chemical in a diabetic person, in a diseased person. What is the fate of a chemical in a female? What is the fate of a chemical in a male? That all falls, we had been discussing it in principles of toxicology, that these are the factors affecting the science of toxicity. So all these factors, they count. So what we do, we include in medical toxicology is all those things. That just to introduce you with the subject of medical toxicology. We shall keep on talking further on this very particular subject. So take good rest at home, and listen to my lecture again and again, and you will come across with many good points, and we shall continue deliberating on medical toxicology at a later time also. Thank you.